Hello everyone, today I am honored to introduce to you our perspective paper, Precision Microbial Regulation, Strategies for Modulating GIT Microbiota for Host Health. A stable and balanced gastrointestinal microbiota plays a crucial role in maintaining host physiological stability, promoting growth, and controlling diseases. So, is it possible to precisely regulate the GIT microbiota to shift it toward an ideal state and thereby enhance host health? In recent years, beyond antibiotics, new strategies for GIT microbiota regulation have been developed, including fecal microbiota transplantation, synthetic microbial communities, genetically engineered microorganisms, phages, and nanomaterials. We believe that optimizing the effectiveness, stability, safety, and cost efficiency of these strategies will be closer to practical application. Additionally, leveraging existing microbial knowledge to support targeted regulation strategies is essential, such as identifying regulation windows, analyzing parameters to recognize biomarkers, and monitoring the gastrointestinal environment. The highlights of this paper are as follows. First, emphasized the necessity of targeted strategies in regulating GIT microbiota. Second, reviewed precise regulation strategies for GIT microbiota, including FMT, syncoms, GEMs, phages, and nanomaterials. Third, highlighted that integrating these strategies with new microbiological discoveries can enhance the precision of selecting intervention timings and identifying microbial biomarkers. Given that conventional methods have difficulty in specifically targeting GIT microbiota, we propose 5 relatively targeted regulatory strategies. For each strategy, we have summarized their mechanisms, efficacy, safety, clinical outcomes, and optimization approaches. Microbial targeted regulatory strategies aim to maintain the homeostasis of the gastrointestinal environment. By stabilizing microbiota and their metabolites, dendritic cells, regulatory T cells, helper T cells, and macrophages can function effectively, ultimately achieving immune homeostasis in the host's gastrointestinal tract. Although the aforementioned strategies can theoretically target the host's gastrointestinal microbiota, microbial regulatory strategies require further optimization to improve precision, enhance stability, ensure safety, and reduce time and economic costs. These efforts will provide a solid foundation for their eventual widespread application. Integrating targeted regulatory strategies with expanded microbiological knowledge will enhance their precise application. For example, monitoring the gastrointestinal environment to determine intervention timing, analyzing microbial parameters to identify key biomarkers, or implementing microbial regulation during critical windows such as early life. These efforts aim to ultimately achieve the goals of microbial regulation. This paper explores the potential of targeted strategies for regulating gastrointestinal microbiota to promote host health and reviews the mechanisms, effectiveness, safety, and clinical outcomes of these strategies. The findings suggest that fecal microbiota transplantation, synthetic microbial communities, genetically engineered microorganisms, phages, and nanomaterials hold promise as next-generation approaches for gastrointestinal microbiota modulation. Optimizing these strategies in terms of efficacy, stability, safety, and cost-effectiveness will facilitate their practical application in precisely influencing gastrointestinal microbiota. Cutting-edge microbiological knowledge will further support these regulatory strategies, such as selecting appropriate microbial intervention windows, identifying key microbial biomarkers as targets, and monitoring the gastrointestinal environment to seize optimal timing for intervention. In the future, the application of these strategies is expected to enable dynamic adjustment of gastrointestinal microbiota based on physiological conditions.